Algebra. This is lesson 22 called Rationalizing the Denominator. Bear with me because this one's kind of crazy. There is, sorry, someone's on the intercom. Okay. There is a crazy formula at the end of this that you may have to use, but it will take practice. Just take it slow. And again, I don't know what else to say. It's just wild, but I'll show you how. We'll just take it slow. First things first, we cannot have a radical in the denominator. That's a big no. We have to get rid of the radical in the denominator by multiplying the top and the bottom by whatever's in the denominator. So for example, I've got 5 over the square root of 2. We can't leave it like that because again, big no-no. There are no radicals in denominators. So I multiply the top and the bottom by the square root of 2. So at the top I've got 5 times square root of 2 over square root 2 times square root 2, which is the same as 5 square root 2 over, you put the both of these under the same radical when you're multiplying. So I've got one big radical with 2 times 2 under it, which is 4. 5 square root 2 over the square root of 4. The square root of 4 is 2. So I end up with 5 square root 2 over 2, which means that the radical's gone, happy face. That's what we want. Sometimes you might have a radical that has an index in it, and the cap will come off. If there were like maybe a little 3 here, it's not going to be that easy if you thought that part was easy. This is where the formula is going to come in. So it's going to take me a little bit to copy this down, but you can see also in your book that it's just the same that I'm writing down there. At the very bottom of that instruction box is a formula that you need to use if you wind up with any radicals with indexes. So it says that a over the square root of b with a little, I think it's a p, with a lowercase p, I guess for power, and then a little r here. So all this means is whenever you see problems like this, the number that's up top here is going to be your a. The number under the radical is going to be your b. If the radical has an exponent, that's the little p, and if it has an index, that's the r. So you solve it according to this. You put again, bear with me. It's the same thing that you're reading as well, hopefully. But you put at the top the little r, then the radical. Underneath the radical is b raised to the little r minus p. So at the top, whatever your b is, stays under there. Whatever the r is, goes here. And then the r is also going to go here, minus p. And that's going to be over the same thing, it looks like. R in our index part over b r minus p. Like this. Okay? And that's going to simplify to the thing they have here at the end is a little index, little r, square root b r minus p over b. They're ending up without a radical at the bottom. So let's study the example that they give us here. They give us 2 over the cube. There's another announcement. Not us. Okay. 2 over the cube root of 5. So, according to the formula here, 2 is our a. So 2 equals a. Our b would be 5. 5 equals b. And our 3 would be our little r. 3 equals little r. There's not a p because the 5 isn't being raised to any power unless they want you to use 1, which they do. So remember, 1's always implied, so the little p is going to be 1. Right? Once you've listed out what each of your numbers are for the formula, then it's just a matter of plugging them into their spots. So this is the same as this. We're going to move it over here. So at the top here, my little r is 3. Put the 3 here. And then the b is 5, r minus p, so 3 minus 1, over square root, little r is 3, b is 5, r minus p, 3 minus 1. Okay, all I did was plug in my numbers where the letters needed to go, making sure this is right. Okay. Then they've got it to where it's going to equal, I'm going to just jump down here, so equal a, what's our a? 2, 2, the little r is 3, the b is 5, and then r minus p, so 3 minus 1, over, what's b? 5, okay, so now I've got it like that, and then you can go ahead and try your best to simplify. So I can go ahead and minus the numbers up here, so that would be 2 cube root 5 squared over 5. 5 squared is 25, so I've got equals 2 cube root 25 over 5. And that's all we got. Don't try to do square root of 25 because it's not the square root, it's a cube root. The index there is 3. Guys, I know that's long and strange and complicated, but take it slowly in steps. You have the formula for you, and then when you're given the problem, identify what each letter in that problem is going to be, and then just plug in the numbers as you go into the formula. Alright, try the classwork examples yourself. Go ahead and pause the video, and then try the classwork. Replay the video when you're ready to go over the answers and see how you did. Make sure you mark what you don't understand too on the way. Go ahead and pause it. Alright, so for that first one, we've got 4 over the square root of 7. What we do here is we multiply the top and the bottom by the square root of 7. So I've got 4 times the square root of 7 over square root of 7 times square root of 7. So here we got 4 square root 7 over, remember when you're multiplying, you put them all under the same radicals, so 7 times 7, which is 49. I just kind of skipped here. So at the top I got 4 square root 7 over 7 because square root of 49 is 7, and I got rid of the radical in the denominator. So I rationalized the denominator. The next one is 5 square root 2 over square root 6. same thing. I can just multiply the top and the bottom by the square root of 6 to simplify. So here I get 5 square root 12, and I'm just doing 2 times 6, and then putting 6 times 6 under the same one, which is 36. So I get 5 square root 12 over the square root of 36. The square root of 36 is 6, so that gets rid of my radical. I get 5 square root 12 over 6. Now the tricky one. The problem is 3 over the cube root of 12. My a is 3. I'm going to write down what each number is. A equals 3. The little r is also 3. The b is my 12, and the p is a 1. Again, it's always in p equals 1. So now I'm just plugging in the numbers as I go. So here I've got 3 square root, b is 12, 12, 3 minus 1, 3 minus 1, over the same thing. Cube root 12, 3 minus 1. I'm just merely putting in the numbers with the letters they match, which is going to give me a. My a is 3, 3, cube root 12, 3 minus 1, over my b, which is 12. And I can simplify here. So I got 3 cube root 12 squared over 12. So 3 cube root, sorry, my writing's getting bad. 12 squared is 144 over 12. Did I do that right? Not so much. Oh, they're not done because they want to simplify more for 144. If you did that on a test, I'd accept it. But they simplify the 144 by doing the prime factorization. I'll show you that tomorrow because this video is already getting too long and complicated with this formula. But if you got at least to there, then that's good. So replay the video if that's just crazy. Check the ones you missed. If you missed all of them, it's really okay. We'll go over them tomorrow, okay? Bye.